On this problem, we're given a demand function, and we're told that Q is the number of units in demand, and D of Q is the price per item in dollars. So with a demand function, we want to be a little bit careful. Demand functions always connect together price and quantity. But sometimes they're set up that Q is the independent variable, and sometimes they're set up that P is the independent variable. So it's not always super easy to deal with these. So let's go ahead and identify which is which in our case. So in our case, the price is going to be given by D of Q, all right, because D of Q is the price per item. And then Q is going to represent our quantity, the number of items. All right, so in our case, because we're given that we want to figure out if 10,500 units are in demand, what price should we charge for each item? So we don't know the price, but we do know the quantity, Q, is going to be 10,500. So what this leads us to do is we're going to go ahead and replace each of the Q's in our function with 10,500. So we can calculate D of, instead of Q, 10,500. Is going to be negative 0.007 multiplied by, instead of Q, 10,500 plus 84. From here, I'm probably going to get my calculator out and do this first computation. We get negative 73.5 plus 84. And we'll finish it up by combining these numbers together. We get 10.5. Now, we probably want to ask ourselves, what kind of units are we looking at here? We have a value not for Q, but for D of Q. And D of Q is the price per item. So price per item, it's going to be in dollars, so that's $10.5. All right, hope this helps out. As you're looking at demand functions, try to identify exactly which variable is independent. In our case, Q is the independent variable, and what the function actually represents. D of Q in this case is going to be the price per item, the price in dollars per item. Hope this helps out. Good luck.